Hey there, geometry class. This is the video for the Pythagorean theorem and distance worksheet. And the first question here says the perimeter, which means the distance around, of a rectangular sandbox is 32 yards. So if I add up this length, this width, and this width, I should get 32. Now the length and the width of the sandbox are consecutive odd integers. And it gives you examples of consecutive odd integers. Consecutive just means one after the other. So like 45 is an odd integer. What would the next odd integer be? 47. Or you could say the one before it, 43 and 45, are consecutive odd integers. Okay. The question asks us to find the length of the diagonal. So what we really want is this diagonal right here. And somehow we have to find that length, knowing that the sides add up to 32 and the consecutive sides here are consecutive odd integers. Well, let's say we call this side x. And let's say it was 1. Okay, the next odd number would be 3. So to go from 1 to 3, I have to add a 2. So that would mean that this side would have to be x plus 2 to get to the next odd number. Okay, it's a rectangle, so opposite sides have the same length. So if this side, the left side's x, the right side's x. If the bottom is x plus 2, then the top is x plus 2. Okay. Now that I figured that out, I could write an equation that would help me find x. Because I know that when I add all those up, I'm supposed to get 32. So my equation would be x plus 2 plus x plus 2 equals 32. Now once I solve that equation for x, then I'm going to know the width of the rectangle and the length of the rectangle. And from there, I could use the Pythagorean theorem, a squared plus b squared equals c squared, to find this diagonal. Remember, the diagonal is always, or the hypotenuse is always c in the Pythagorean theorem. This is going to be the right angle right here, and that side c is always across from the right angle. So when you set up the Pythagorean theorem, a squared plus b squared equals c squared, make sure that the diagonal is c. So x could be whatever x is after you solve this equation. That could be a, and then you'll do a squared. Whatever x is, add 2 to it, that'll be b, so plus b squared equals c squared. And solve the Pythagorean theorem. If you're having any difficulty solving the Pythagorean theorem, please come see me. All right. You have a large rectangular box here with these dimensions, 9 feet, 15, 12 feet. We want to know what's the length of the longest rod that you could fit in your box. Well, the longest rod would go from the back corner at the top to the front corner at the bottom, right? Or we could have gone the other way, but this diagonal. And how do we find that? Well, I've drawn in this right triangle right here, and I know this side of the right triangle, this leg, I know that's 12 feet, because if this is 12 feet tall on this side of the box, then this back here is also 12 feet tall, so that's got to be 12. Okay, now I would be able to find the length of the blue rod if I knew this leg down here. But I don't know that leg down there. But I could find it by using Pythagorean theorem on the bottom right triangle right here, where 15 is a leg, 9 is a leg, and then I could find this side right there. So it would be 9 squared plus 15 squared equals c squared. That would give me that side c. I'll go through the Pythagorean theorem one time with you here. This is going to be 81 plus 225 equals c squared. If I take and add 81 and 225, oops, then I'm getting 306. And that equals c squared. Take the square root of both sides, and I'm just going to say that c is actually equal to, I'm not going to take the square root of 306, I'm going to say it is the square root of 306. Okay, now this triangle on the bottom of the box, where 9 is a leg and 15 is a leg, that triangle had this diagonal be the hypotenuse. But now when I'm looking at this triangle, where the big blue rod is the hypotenuse, 12 is a leg, and this diagonal down here is a different leg. Now this isn't the hypotenuse anymore, it's the leg of that triangle. And up here, the blue rod is going to be side C. So I'm going to say that 12 squared, I'm going to use the Pythagorean theorem again, 12 squared, that leg squared, plus this leg down here, it is the leg of this triangle, and it is the square root of 306 squared equals c squared. Okay, so this diagonal down here was the hypotenuse of one triangle, this triangle, but it was the leg of another triangle. Now if I square 12, that's 144. Now what is the square root of 306 squared? Well, square roots and squares undo each other, so it's just 306. And that equals c squared. I'm going to let you take it from there. All right, the next problem says a circle has been drawn on a coordinate plane. Now using the distance formula, so we can't use Pythagorean theorem, it says using the distance formula, show that the origin, which is this point right here, 0, 0, is truly the center of the circle by proving that segment OA is congruent to segment OB, which is congruent to segment OC, which is congruent to segment OD. Congruent means that all of those segments have the same length. Remember, numbers are equal, but things are congruent. And since this is a segment, I don't want to say segments are equal. OA and OB aren't the same segment. They aren't equal, but they are congruent. They are the same length. So I wrote the distance formula for you here. And I wrote out the points, the coordinates of the points next to each one of these. So A is at 3, 4, D is at -4, 3, etc. And to find these, the measure, the little m next to OA means find the measure of segment OA. All you need to do is plug the numbers into the distance formula. So I said that 0, 0, 0 here was x2, y2, and 3, 4 was x1, y1. So x2, which is a 0, minus x1, which is a 3, that quantity squared, plus y2, which is a 0, minus y1, which is a 4, that quantity squared, the entire thing square root. Now if I do 0 minus 3, that's -3, and -3 squared is -3 times -3, which is +9, plus 0 minus 4, which is -4, and that -4 squared is -4 times -4, which is +16. The square root of 9 plus 16 is the square root of 25, which is 5. So the measure of segment OA is 5. Now use the distance formula to find the measure of OB, the measure of OC, and the measure of OD. And be sure that you are showing me your work. Notice how I said OA, this distance OA equals, and then I showed my work. So show your work on all of those. Remember, you can pause the video. All right, so the last problem is the doozy. We're going to use R and S on this coordinate plane. And we're going to show with pictures and explain with words how the distance formula is related to the Pythagorean theorem. So remember, you can pause this video because I have already worked this out for you, so you can pause it. But basically, I wrote out in words the distance formula is derived from the Pythagorean theorem. To find RS, you can use the Pythagorean theorem by drawing a horizontal line through S. Here it is in the picture. A vertical line through R, here it is, and line segment RS. A right triangle is created, and RS is the length of the hypotenuse. The length of the horizontal leg squared, A squared, right? The length of the horizontal leg squared, plus the length of the vertical leg squared, is equal to the length of the hypotenuse squared. That's what the Pythagorean theorem says, right? Now underneath I wrote a squared plus b squared equals c squared. A is the horizontal leg squared, b is the vertical leg squared, c is the hypotenuse squared. How do you find a horizontal distance? x2 minus x1 squared. How do you find a vertical distance there? y2 minus y1 squared, which would equal the distance squared, the hypotenuse, right? And I put a d right there. That's going to equal that distance squared. Solving for d, solving for this d right there, I get the square root of all that stuff right there. That's how the distance formula is derived from the Pythagorean theorem. Off to the left here, I have solved, I have found RS by using the Pythagorean theorem, and I've shown on my work. And then I have solved using the distance formula, showing on my work. So I've used words and I've used the diagram to show how the distance formula is related to the Pythagorean theorem. Okay, that's mastery level stuff there. All right, so remember, you can always pause the video when we're going through this. Obviously, you couldn't write all that stuff down as fast as I could just say it when I already had it done for you. So you can always pause it, back it up, go forward. It's okay if you want to use a lot of my words here, but I would like for you to try to do this using your own words, okay? All right, and that's the end of Pythagorean theorem and distance.